Welcome back, guys. This is question 2.18 and the statement of it is, given this circuit shown in figure P2.18, find A, the value of IA, the value of IB, the value of V0, the power dissipated in each resistor and the power delivered by the 50 volt source. So this is the circuit diagram. Here we have this source which is of 50 volts. 4 ohm resistor is connected in series with it, while 2 resistor 20 ohm and 80 ohm. You can see that these are connected in parallel with each other. How to see that whether these are in parallel or not? If the two legs here, you can see that the 2 points or the 2 junctions here are common in between them, and we can also draw them here as well. Okay, it is like this one. Okay, this is the source and these are the 2 common points. We can see that here this and this, these 2 legs of these 2 resistors, okay, these are connected here. So that's why these 2 are in parallel with each other, and these 2 are also in parallel with this source which is of 50 volts and 4 ohm as well. Okay, so these 3 are in parallel with each other. And what is the voltage here? This is given, this is V0 here, so therefore this V0 voltage is also here as well. Okay, so what are the currents? Let me show the currents here as well. This is IB, this is IA. Okay, and let me represent here this I0, which is the current supplied. Okay, so we can very clearly see here that this V0 is equal to the voltage across 80 ohm, across 20 ohm, and the voltage which is generated by this 50 volts minus the voltage which is subtracted by this 5 ohm. So let me call this voltage, the polarity of it will be plus minus. Why? Because this is the voltage dissipating device, and the current here is I0, and the voltage, let me call it V4. So this is the overall data we have. Now on the basis of it, what will be the points which we should know here is that the first law, and we are going to practice all those laws here. The first law is Ohm's law. Okay, so where will we apply here the Ohm's law? Here the value of V0 is equal to what? That is the current through this resistor 80 ohm and the value of this 80 ohm. So this is what? This is IB, which is this current. Okay, this is IB multiplied by this 80 ohm. Okay, why? Because V is equal to IR is the law according to Ohm's law. Similarly, this voltage, if we see that these 2 are in parallel, this is a similar voltage which is across this 2 ohm as well. So we can also write it the 20 ohm resistor multiplied by the current through it, and that is IB. This is also V0. Okay, if we want to see that what will be the voltage here, we can see that this is again V0 here as well. Okay, and that is what we have here. The second law here we are going to apply is the Kirchhoff's voltage law. Okay, so what is KVL? Let me look at this loop. Okay, when we are going to take a look at this loop, we can see that here this is, let me have this current which is I0. It is now entering through this negative terminal, coming out of this positive terminal. So this is the voltage rise. Here it is entering through this positive, coming out of this negative. This is voltage drop, and this 20 ohm resistor, and we know the voltage drop across it, and that is V0. Okay, so if we want to write the equation here, if this is Vs, so we can write here what? The KVL equation for it will be Vs, which is the voltage rise, minus V4, which is the voltage drop here, and this 20, which is again the voltage drop, and that would be minus V0. This must be equal to 0. Okay, so this is another equation which we are going to see here. And the third one here is the KCL. We are going to see here the KCL as well. This is the I0. So I0 is going towards this node and splitting into 2 parts, IA and IB. So here this I0 is equal to IA plus IB, and that is Kirchhoff's current law equation. So now we have three equations. We have this equation, let me call it A. This is equation B, let me call it here B, and this is C. Okay, these three equations, or let me also call it equation A prime as well. Okay, so this is the equation A prime. So now we have these four equations, and on the basis of them, let me calculate the values. Let us compare equation A and A prime, and from it we can very clearly see that the left hand sides of both of them are equal. So that's why AIA multiplied by 20, that is equal to the IB multiplied by 80. Okay, so dividing both sides by 20, IA is equal to what? That is 4 multiplied by IB. This is another equation, let me call it 1. Okay, let me take it and put it in equation C. What will we get? Here putting it, we will get I naught is equal to, the value of A is 4IB plus IB, and from it we will get the value of I naught is 5IB, and that is what we have got. Now let me take this equation B, and from it we can clearly see that Vs minus V4 is here, this 4 ohm. So applying the Ohm's law here, I into R, so I here is I naught, so I naught multiplied by 4 and minus V naught, that is equal to 0. Now let me put all these values here. So it will be Vs is 50 because the source voltage is 50 here, minus the value of I naught is 5IB, 5 into IB into 4, and the value of V naught, we can take any of these equations. Sorry, this is A. Okay, we can take any of these equations, but as here IB is involved, so let me take equation A here. So it will be minus IB into 80, and that is equal to 0. Okay, so from it let me simplify it, and simplifying it, taking it to the other side, and this one is here, so it will be 50 is equal to 20 IB plus 80 IB. Okay, so from it we can clearly see that the value of IB will be equal to 50 divided by 100, which is 0.5 amperes. Okay, so this is what, this is the value of IB. IB is known. From this value we can put it here in equation 1 and clearly see that the value of IA will be equal to, the value of A is 4 multiplied by IB, so that is 2 amperes. Okay, so this is IA. Okay, we can take IA, IB, put them here. Okay, and from this equation the value of I naught is equal to, or the generated current, which is the total current, that will be equal to 2 plus 0.5 is 2.5 amperes, and that is what, that is the value of I naught. Okay, we can take these values, put them here, either IA, either IB. Okay, so let me put them here. If putting IB here, what will we get? Putting it here, the value of V naught is equal to what? The value of IB is 0.5 multiplied by 80. So this will be what? This will be 40 volts, and that is the value of VB. Okay, so we have found some values. So let me go to the parts of it, find the value of IA. So we have already found it out. The value of IA is here. This is part A. The value of IB, that is also found out, that is here. The value of V naught, okay, we have also found it out. This is C. Okay, the power dissipated in each resistor. Okay, so to find out the power dissipated in each resistor, let me remove some parts of it here. So let me remove it. For the power dissipation, we know the formula. to find out the power dissipated in each resistor, it will be the I square into R. Okay, to find it across 4 ohm, it will be P4. Okay, it will be I naught square into 4 ohm. The value of I naught is what? That is 2.5 whole square into 4. The value of the power dissipated at 20 ohm resistor is what? That is IA whole square into 20. Let me put the value of IA, which is 2 square into 20, and the value of the power dissipated across this 80 ohm, that is the current square, IB square, multiplied by this 80. Okay, so it will be the value of IB is what? That is 0.5 whole square into 80. You can calculate it, and then the answer of it will be here. Okay, also the power delivered by the 50 volt source. Okay, so this is the power delivered by the 50 volt source. Let me move down somehow. So part E, for the source, the value of power delivered is source current into source voltage. Okay, VI or IV, similar thing. So the current it provides is I naught, while the source voltage is 50. Okay, the current I naught, as we have found out, is 2.5 multiplied by 50. So finding it out, it will be 125 watt, and that is what? That is basically the answer of part E. If you add them all, okay, you add them all, these are the power which are dissipated in each of the resistors, you will see that the power source which is generated is equal to the power which is dissipated. Okay, so you should add them all, and all of these values will end up with 125 watt. Okay, so that's the solution of question 2.18. Today we have solved it by applying the fundamental theorems of the circuit theory. If you have any question, you can ask me in the comment box. See you soon.